I had to recharge my camera battery, so I've sort of gotten ahead of you. Need some better light there, hey? So I traced the circuit enough to know that the B port all seem to go up to the LED, and there's some resistors underneath the display that they go through. And then there's 3 bits on the C port that come out here, and they go right to the display. So I'm thinking that those bits on the C port are the control lines for the display. Now, using my meter in the diode function, it doesn't have enough voltage to light the LEDs, so it was hard to figure out what went where. So I wrote a program to help me figure out what's going on. So the gist of the program is I set 1 bit on the B port high, all the rest low, and then I left the C port tri-stated, and I only enabled 1 bit at a time. So I enabled one of the control lines, I set it high, I set it low, then I tri-stated again. Then I set 2 on the B port high, 2 bits high, and I enabled another control line and did the same thing, high, low. Here comes our helper. High and low, and then on the third time I set 3 bits high. So what this program is supposed to tell me is, if it's a common, get out of here. If it's a common cathode display, then it'll be active low, and I should see 1 bit lit up, one segment lit up. If it's a common anode display, then I'll see 7 segments lit up and only 1 dark. And then by doing different number of bits on each of the control lines, I should be able to tell which control line controls which digit. So, like I said, I've already run this and I know what it does, but let's power it up and show you. So there's a lot of LEDs lit up, a lot of segments lit up. So it turns out to be a common anode display. So you have to drive the enable high, and you have to sync on the B port to get the LEDs to light up. So you can see on this one here, there's 1 segment that's dark. So that's my first control line I tried. And on here there's 2 segments dark, so that's the second one. And on here there's 3 segments dark, so that's the third one. So I know from this that RB0 controls this A segment here, RB1 controls the B segment, and RB2 controls the C segment. And I'm going to assume that that's the way it works all the way up to the line. So RB7 will be controlling the data point, decimal point, I believe. So also in tracing this out, it looks like RB7 goes to this switch as well as to the LED, and RB6 goes to this switch over here as well as to the LED. And those bits are also your ISP bits. They come over here to these signals over here on this J1. And it's not unusual for these small micros to have multiple functions on a couple of pins like that. But with 24 I/O lines on this, that seems needlessly complicated to me. But I figure Kidde probably has some common program that they reuse over and over, and that's the way they did it for starters, and so they just continued to do it that way. So the next step that I'm going to do is I'm going to my help will get out of the way. I'm going to write a program on a timer interrupt that will actually multiplex this display and allow me to display actual digits like 0, 1, 2, 3, 4, 5, and so forth and so on. So we'll have something we can work with. And still haven't figured out what we're going to do with it, but we'll figure out how these switches work, multiplex the display, write a little self-test program. And then we'll have the basis of some kind of product, whatever it might be. So until next time.